Hello, everyone. This is Dr. Vaughn, and I'm going to record a video for our class experience for Friday, which for me is tomorrow. And I don't normally do this, but I'm going to actually go through some of the homework assignments that you have in Alex. I don't mind doing this. I really want to see you get off to a good start. And I'll use this as an opportunity to kind of talk about some of the concepts. And in particular, what I'd like to do today is give you an introduction to these alternative base systems, which I think is some of the hardest content you'll have over the course of these first couple of weeks. So today I intend on showing you a brief introduction to these base systems, and we'll talk more about it in class next week on Wednesday in our regular synchronous Zoom session. Um, please look for this. You already found it if you're watching this, but watch the announcements also for a couple of other supplementary videos that I found that I'll post links to for you to watch for a little bit more information about this. I don't have a separate expectation of you this week for posting in a discussion board, say, really, you earned your participation for this week on Wednesday. If some of you were not able to come to class on Wednesday, please just send me a message in the message center or by email, and I will make arrangements with you to make sure that you don't miss out on at least some of the participation, maybe all of it for week one, because you didn't make it in for the Wednesday class and didn't know that we were meeting in this alternative format for Friday, the second day of the week. So, with that being said, I want to remind you that most of the content that we're doing is in section one, but you can always kind of tell where the content, when you're working through your homework, comes from by clicking to the appropriate book. So, when I went to this first problem and I clicked on the ebook, it opens up section 1.1, which is where this idea of inductive and deductive reasoning. And if I go forward a little bit, you're going to get into the pattern recognition and interpreting and estimating things from graphs. And in section 1.3 is the part that I just started to talk about. I know many people had to leave with the Paulius forced problem solving process. So, one of the things that I would like to ask you to do, in addition to listening to and watching these videos that I put out under the announcements, is to please look over at least chapter one of your book. And as we get into the alternative base systems, I think you're going to find that some of that content is actually all the way up in chapter four. So, with that being said, I'm going to just work my way through just a few selection of problems, and then we're going to skip up to the base system problems near the end. We did talk a little bit about this on Wednesday, the first three terms of an arithmetic sequence. What an arithmetic sequence is when you're adding the same amount or subtracting the same amount. Every time you get one of these problems, you're going to get a different set of numbers. For me, they gave me 11, 18, 25. So what I'm going to look at is what am I adding or subtracting to get from one number to the next. That's what an arithmetic sequence is. So 11 plus 7 gets me 18, plus 7 is 25. So the next two numbers in the sequence are going to be plus 7 again, that's 32. And plus 7 again after that would be 39. And then I'll check my answer. So you'll have a couple more of this kind of sequence and pattern recognition. We started to do a problem, at least in one of the classes, about these boxes and the different kinds of diagrams. In picture number one, I have a 4 by 1, 2, 3, 4, 5, 6. 4 by 6, so there's 24 squares. This is 3 by 6, so that's 18, 24, 18. 2 by 6, so that's 12. And the next one then would have 1 by 6, if that pattern were to continue. So the next figure would have only 6 squares all in a straight line, because we've run out of column room. Now let me skip up ahead, and we can always come back, and I want to try to get into these base system problems. I think they start right around 18, 19, 20. These are all place value. We'll come back to some of that. Oh, I'm sorry, it's more like 30. All right. So So this is problem 31. And what I want to point out is you have these digits 1, 0, 2, 2, and then a base. It's base 3. Now, in a base 3 system, you only have the digits 0, 1, and 2. Like in our base 10 system, we have 10 fingers, base 10. We have digits 0 through 9. So whatever the base is, the digits that you're allowed to use is one less than that because it includes 0. Now, if that base is bigger than 10, what they'll do is start to use letters. In a base 12 system, for example, we have to have symbols for 0 through 9 together with a symbol for 10 and then a symbol for 11, in which case we'll use T for 10 and E for 11. In a hexadecimal, which is base 16 system, we don't want to keep using T and E, so instead we go 0 through 9, and then for 10 we use A, for 11 we use B, for 12 we use C, for 13 we use D, for 14 we use E, and for 15 we use F. All right, so just if you start seeing letters in there, it's because your base system is bigger than the ones that we have symbols for. Now, what this stands for is place value. So 1022 is 2 in the ones digit, 2 in the threes digit, 0 in the 3 squared digit, and then 1 in the 3 cubed digit. So in our base 10 system, you have powers of 10, ones, tens, hundreds, thousands. In base 3 system, you have powers of 3 instead. 2, 3, 3 squared, 3 cubed, and then this is how many you have. In previous problems and in your book, you'll see the idea of expanded notation. So the way in which I'm going to count in the base 3 system, the next number that came after that, is I want to add 1 to this. 1022 would make this 1023. But I can't use 3, so now I actually need to carry that over and bump this up to a 0, and now this becomes a 3. So I have 1030, but again I can't have 3, so now I need to make that a 0 and carry that extra digit over to the next place value. So the next number in the base 3 system is going to be 1100. Let's try it with this base 9 system. 837 base 9. The next number, I'm going to add 1. And as long as that's not bigger than 9, then I have no problem. Up here, I was getting to 3, and that's why I had to carry over into the next place. If I don't get a number bigger than 9, then the next number is just the next number, 838. It's only when I get up to the base value in one of those positions that you need to carry over. And when you're doing subtraction, you need to borrow from, going the other direction. So this one I had to carry twice. Carry the 3 over to make that a 3, and this becomes a 0. And then carry the 3 over to make that a 1, and then that became a 0. In this one, 838, no problems with the base. So I don't have any carrying that I have to take care of. All right, let's try another one of those. All right, so here now you're seeing those letters in this base 12 system. I lied to you. The other text used E and T. Now they're using A and B. So A stands for 10 and B stands for 11. So I have 11 in this position of 12 possible. That's the biggest number you can have. I have 11 in this position and then a 5 in this position. So if I added 1 to that B, that becomes 11 plus 1 is 12. 12 is the base, so I have to make that a 0 and carry the 1 over to the next place. That B, which is 11, now becomes a 12, which means now I need to carry it over and make this a 6. That 6 is not a 12, so I'm fine there. But adding 1 made this a 0. It's like when you add 1 to 99, right? You got to add 1 to the 9, carry it over, and make it a 0. Carry it over and make it a 0. Same thing's taking place here. So this B is going to become a 0, carry the 1. B is going to become a 0, 12, carry the 1. I'm going to have 6, 0, 0. This one, I have 3, 7, C, D in base 14. All right, count with me here. So 9, 10 would be A, 11 would be B, 12 would be C, and 13 would be D. So this D stands for 13. So when I add 1 to that, it becomes 14. 14 is the same as the base. So that now is going to become, I have to carry it over. This is going to become a 0, carry the 1 over. C, however, was not 13. C was 12. So when I add 1 to the C, that's going to become 13, which remember is represented by the symbol D. So when I add 1, that's going to become a 0, carry the 1. This has become a D. No more carrying is necessary. So 3, 7, D, 0. Oops, I put it on the wrong one. Make sure you're using capital letters and the number 0, not the letter O. All right, now I'm going to skip ahead and we're going to do maybe 1 or 2 more of these base system problems, and then I'm going to let you try it. All right, so this is an opportunity to look at the octal system, which is base 8, and its binary equivalent, which is base 2. So the nice thing about base 8 and base 2, because 8 is a power of 2, 8 is 2 to the 3rd power, is that each of these place values expands out to being 3 binary digits. So the 0 in the right-hand one is going to become a 0 in 000 in base 2 at the end. The 5 in octal is going to be 101, and that's going to come to the left. So now I have the 5, 101, and the 0, 000, and now up front the 3. 3 is going to be 011. So that's how you can translate from octal into binary. Now I'm going to go the other direction. I'm going to go from binary into octal. So now I want to start with the right-hand side. 101, find it on my chart, is represented by a 5. The next 3 digits, 001, is going to be 1. That goes to the left. And then, okay, 001. I used 2 of those zeros, so now I have 010. 010 is a 2. And then I have this 1 left over 1, which is just 1. So 1 from here, 2 from those 3 digits, 1 from those digits, and then 5 from those digits. All right, so this has been a very brief introduction to how we actually represent things in an alternative base system. Now, what you should practice is, first of all, just writing things in a base system, right? Taking something from base 10, which is the one you're mostly familiar with, and putting it into, say, base 8 or base 7 or base 6. And you won't always have this translation table available. The next thing you should practice is converting between one base into another one. Later, what you're going to start doing is things like adding, subtracting, and multiplying in a different base. These are difficult exercises, but the way in which you can be successful is think about the way in which you take away from place values. So I'll just give you one example here on part A. To subtract, I'm going to take the 3 in the ones digit and subtract the 2 in the ones digit. I'm going to have 1 left over in the ones digit. In the next position, I have 4, and I need to take away 5. So I don't have enough in the second position to take away the 5. So I need to borrow from the 2, make that a 1, and cash it in for 7 more in addition to the 4 that I had before. I had 4. I get 1 from the borrowing process, which becomes 7. So really this is 11. 11 in the middle slot. Now I can take away 5, which means that I'll have 6 left over. The key thing is, again, I'm never using a digit other than 0 through 6. And finally, I had the 1 left over, take away nothing. And so I'm going to get 161 in that base 7 system. Okay, well, since it's up, and just so you can see that I'm doing this correctly, we'll do part B here. 0, take away 1. I'm looking at the ones digit. I don't have enough to take away. So I'm going to borrow from the 2, cash that in, so I only have 1 left, and that's going to become a 4. Now I have 4 of these things. I can take away 1, which is going to leave 3 in the ones digit. Remember that middle digit, I borrowed 1, so I only have 1 left there. Take away 0. 1 take away 0 in the middle is 1. And then up front, I have 3 minus 1, which is 2. So subtracting 320 minus 101 gives me 213. I'm starting with the least significant digit, just like we do in our regular subtraction process, and working my way to the left. All right, and I got it correct. You're also going to try multiplication and division. Again, these will get harder and harder, but I'll put out a couple more videos, and I'll also we'll talk about it much more when we get back into class on Wednesday. Thank you for your understanding. We have a lot to talk about, and even on Monday, I may even put out another supplemental video for you, but I wanted to give you a little bit of content to for you to engage with tomorrow when we're not going to be meeting via synchronous Zoom. Thank you very much, and I hope you have a wonderful weekend. Please send me any messages in the message center. I'll talk to you again soon.